Okay, dun sa previous video natin, diniscuss natin yung arithmetic operations on vectors. Now we have two remaining operations, which are the dot product and cross product. But before we get to those operations, uh, let's discuss first the concept of unit vectors. Okay, so using these unit vectors, we will be able to write vectors in another form. Kasi for now, ito pa lang yung alam nating way for writing vectors, where we actually list the components of the vector inside these triangular brackets. Okay. So after this lesson, we will learn another way of writing down vectors. So what is a unit vector? A unit vector is a vector of length 1. Okay. So, or magnitude. Yeah. Maybe let's use magnitude just to be consistent with our terminology. So a vector of magnitude 1 is called a unit vector. Okay. So in R2, meron tayong dalawang unit vectors. We call the vector with components 1, 0, I, and the vector with components 0, 1 as J. Obviously, yung magnitude nila ay 1. If you want to compute using the formula for magnitude, yung magnitude ng 1 is equal to square root of 1 squared plus 0 squared. Siyempre, equal sa 1 yan. Okay. Anong itsura nitong mga unit vectors na to? Okay. Since alam natin yung components, we can draw the vector by using the components as the coordinates of the terminal point of that vector. So, let me draw... bakit yellow to? Let me use... ito, yellow-green. Okay. So, itong I, if we're going to start at the origin, yan, andito ngayon ang point na, dito rather, andito yung point na ang coordinates ay 0, 1. Yeah. So, this will be the terminal point of the unit vector I. So, ito ngayon yung itsura niya. For J naman, it has components 0, 1. And the point 0, 1 is here. Baliktad ako. Mali. 1, 0 ito dapat. Sorry. Ulitin natin ha. So, yung vector I, yung terminal point niya, will have coordinates 1, 0. So, 1, 0. Ito yung 1, 0. And therefore, ito ang vector I. Yung J naman, yung components niya ay 0, 1. Andito yung point na 0, 1. So, therefore, ito ang vector J. So, vectors I and J are unit vectors that lie along the x and y axis respectively. So, for the special unit vectors in R3 naman, we have I, J, K. Okay. So, I has components 1, 0, 0. J has components 0, 1, 0. And K has components 0, 0, 1. Okay. So, let me draw the x, y, and z axis. So, ito yung z. Ito yung y. Yung positive sides lang yung dinadrawing ko. Ito naman yung x. Okay. So, yung I. So, andito yung point na 1, 0, 0. Andito naman yung point na 0, 1, 0. At andito yung point na 0, 0, 1. Okay. So, therefore, ito yung vector I. Ito naman yung vector J. Mahirap mag-drawing ng straight na line. Ayan. Ito yung J. Ito naman yung vector K. Okay. So, these are the special unit vectors in R3. Now, using those special unit vectors, we can actually do this. Any unit vector in R2 can be written as a linear combination of unit vectors I and j. So, paano yun? So, halimbawa, yung vector v ko, may components na v1 and v2. Okay. From the definition of the sum of vectors, pwede ko itong isulat as the vector with components v1, 0 plus 0, v2. And then, from what we know about scalar multiplication, itong v1 and v2 ay scalars lang naman. Pwede ko silang ilabas. So, meron akong v1 times the vector 1, 0 plus v2 times the vector 0, 1. Pero ano nga uli itong vector na 1, 0 and 0, 1? Sila yung ij. So, we have v1 I plus v2 j. And this is now what's called the unit vector notation. Ito yung vector components notation. Okay, naka-brackets tayo. Dito naman, meron tayong sum. Dito sa unit vector notation, meron tayong linear combination ng I and j. So, ganun din kung nasa R3 tayo. So, kung yung vector W ko ay may components na W1, W2, and W3, okay, this will be equal to W1, 0, 0, plus the vector 0, W2, 0, plus the vector W3 to dapat, and 0, 0, W3. And then, I will factor out these components. So, W1 times the vector 1, 0, 0 plus W2 times the vector 0, 1, 0 plus W3 times the vector 0, 0, 1. Okay? So, W1, ito ay I plus W2 J plus W3 K. So that's how we go from the vector component notation to the unit vector notation. So let's look at a few more examples. Let's do some vector operations on using the unit vector notation. So halimbawa gusto nating i-add yung 3i plus 2j at saka yung vector na 4i plus j. So, ang gagawin natin, i-add lang natin yung mga coefficients ng I and j respectively. So, 3i plus 4i is equal to 7i and 2j plus j is equal to 3j. And then, ang scalar multiplication naman, for example, I want to multiply 6 to 3i plus 2j. Then, I just have to distribute 6 to each of these two. So, meron akong 18i plus 12j. And so on. So, ganun din kung meron tayong 3 components. For example, 3i plus 2j plus k minus, let's say, 4i plus j plus 2k. So you just need to subtract the respective coefficients of the unit vectors. So 3i minus 4i is negative I, 2j minus j is equal to j, and k minus 2k is negative k. So those are special unit vectors, but of course there are other unit vectors in both R2 and R3, and in fact, given any vector, any non-zero vector, we can actually get a unit vector with the same direction. Okay? And the process for doing that is called normalizing a vector. Okay, so to normalize a vector means to find a unit vector with the same direction. So kung ito yung vector ko at ang magnitude niya kunwari ay 2, then the vector with the same direction as this vector will be this. So parallel sila, ang kaibahan lang yung magnitude nitong vector natin ay 2, and of course the magnitude of the unit vector is 1. So how do we normalize a vector? So this is done by dividing the vector with the reciprocal of its magnitude. So halimbawa gusto nating humanap ng find a unit vector parallel to u. So how do we transform u to turn this into a unit vector? So ang gagawin natin, we need to multiply some scalar here. It needs to be a non-negative or rather a positive scalar, since positive scalars will not change the direction of the vector. And that scalar is 1 over the magnitude of u. Yeah. So this vector now is a unit vector, and it is parallel to u. If you want, you can prove this. Okay. So we know that this is parallel because the magnitude of u is positive. Okay. And u divided by some positive number will be a vector with the same direction as u. But how do we show na unit vector ito? Okay. Well, kunin natin yung magnitude niya. Magnitude ng u over magnitude of u. So magnitude ng u divided by magnitude of u. Dapat 1 lang ito. Okay. So now, this is equal to magnitude of u. Yan. Now, when computing magnitudes, pwede nating ilabas itong scalar na to. Yan. Pwede natin siyang ilabas ng scalar. Positive naman ito. So, lalabas siya as 1 over magnitude of u. So, 1 over magnitude of u times magnitude of u is equal to 1. So, indeed, unit vector nga itong vector na sinulat natin. Now, let's work on an actual vector. Find a vector that points in the same direction as this vector. The vector with components 0, 3, and negative 4. Tawagin natin yung vector na yon na w. So that vector w will be v divided by the magnitude of v. So that's equal to the vector with components 0, 3, negative 4 divided by what is the magnitude of v? That's the square root of 0 squared plus 3 squared plus negative 4 quantity squared. So what do we get? We have 0, 3, negative 4, and yung magnitude is equal to, we have 0 plus 9 plus 16, so 25, and square root of 25 is 5. Ayan. So ipapasok lang natin itong 5 dun sa loob as a denominator of the components. So meron tayong 0 divided by 5, which is 0, and then 3 over 5, and negative 4 over 5. So this is now a unit vector with the same direction as v.